Okay, good afternoon. Welcome to the campus of the University of the Virgin Islands. And we're in the Science and Math building on Upper Campus on the St. Thomas campus. We're going to talk about water testing today, and we've got 4 tests that come as part of a kit that we're going to talk about. These are water monitoring kits that are available from a company called Lamont. Okay, and they're a little more advanced than, say, the standard water test that you could do from a fish tank, for a fish tank. And so we're going to talk about 4 different things today: coliform bacteria, nitrate, dissolved oxygen, phosphate, and pH. Okay, so instead of buying a pH meter, which would be the preferred way of doing this probably, we'll just do a colorimetric. These are all colorimetric based tests. Some of them are already set up because they take time to develop. One of them you have to incubate for about 24 hours. And another one we're going to talk about separately is how we would actually do coliform testing in an actual laboratory setting instead of going out to somebody's house and doing this. So we'll start off by looking at coliform bacteria. And what I've got here are 3 of these vials. They call them test tubes in the test kit, but they're just vials. And the positive test is when it turns yellow. The negative test is when it stays red. Okay? And there's an indicator in there that just will change color if I believe it's carbon dioxide gas is generated. Okay? That's the reason you have to incubate it for around, I believe they say, for 24 hours. "48 hours at room temperature." So you don't even really put it in an incubator. You just leave it at room temperature for 48 hours, and they just go ahead and assume. Now, the ones that we can do today are these other 4, which are the nitrate, dissolved oxygen, phosphate, and pH. And again, we're more interested in cistern water, drinking water. So this test right here is the nitrate test, and the cards are really easy to see. They have the directions on them, and they show you the color. And I've already put in the first. This one requires 2 reagents. I've already put in the first reagent and let it sit. And so now I'm going to put in the second one, which I believe is 1 tablet. Yes. Okay. And then hopefully, and what I've done is I've just made up a water sample with a little bit of nitrate, phosphate, not necessarily dissolved oxygen, but and then you shake these up until the tablet dissolves. Now this little sleeve right here is required because this reagent is photosensitive. So they provide this little metal sleeve which you can just use as a sort of a light block. It's not perfect, but it'll do the job. So you shake it up until you shake up, add the first tablet, shake it until it's dissolved, and then put in the second tablet and do the same thing. So this is a 2-tablet test. The rest of them are 1. Okay? And then you just let it sit, and I believe you let it sit for 5 minutes. Okay? Let it sit for 5 minutes, and we gotta make sure that it's dissolved. So you can just kind of invert it. Oh no, it's not. This one's taking a while. Apologize. So we just shake. As an analytical chemist, you get really, really used to doing this sort of shaking. So, making up solutions. You have to mix everything really, really well. Yeah, there we go. I think it's there. And up one. Still just a little bit of tablet left. I'll show the last one I'm going to show you is the much more specific. It's a fluorescent-based technique. It's a powdered reagent, so you know when it's dissolved. Okay, so we'll just let that sit, and then we'll come back to it in a second, and we'll compare it. And as you can see, I got some little tiny plastic beakers. Now, the dissolved oxygen, I've already done this. This one requires 2 reagent tabs. And this is, again, what they call the test tube. But you have to realize that this sample that I made up is a distilled water sample in which I put in some different things. So you're not going to see probably too much dissolved oxygen. But, again, you compare it. You compare this to the color scale. And it's pretty obvious that there's very, very little dissolved oxygen present. This has been sitting for about the 5 minutes that was required. Okay? Now the phosphate test reagent, it's actually a molybdenum-based reagent. And again, they sell this, if anybody's familiar that's watching this, with what we call the Hach test kits. These are very similar to that, except they're a lot less expensive. So again, you put in the reagent tablet and shake it up until it dissolves. Okay, and you might start to see a color change pretty quickly. And then the last one we'll do in this part is the pH. So we'll just shake this up. pH will probably be the quickest one of the whole group. I just took a little bit of potassium phosphate and a little bit of potassium nitrate and dissolved it in solution. And we'll see. And I put a little bit of sodium bicarbonate in to make the pH a little different too. It's 7. Although with the phosphate in there, it's going to be. You don't want to crush the tablet up before you put it in, as you want to make sure you get all the reagent in. But it would make a lot more sense if you could crush it up somehow, because it would dissolve quite a bit faster. And again, these kits are safe enough that a school child could do this. You know, somebody not necessarily at the elementary school level, but junior high or high school, you know, middle school or high school. And like I said, they're a little more advanced than, say, the standard little test kits you would get for aquariums or swimming pools, but a lot of it's based on the same technique. Almost. I'm going to rely on my editor here to take out all the, yeah, exactly, he's giving me the thumbs up. Okay, there we go. So we'll let that sit. Again, it does take a little bit of time for this to develop. And I'm going to set it up like that. And the pH, again, this is just an indicator based. I imagine this is solid universal indicator. And whatever the pH is whatever the color ends up being. And so, and this tablet is kind of a greenish color. And I just dropped one, so. These little, they don't come in individual packets, and so it is kind of a pain. It's kind of a hassle. But this one you'll see, it'll change color almost immediately. Yeah. Okay. As soon as it dissolves, that's just a little bit of a universal indicator that is probably in a little bit of solid potassium chloride or maybe sodium nitrate or something like that won't affect the pH. Okay? So obviously now we've got the color change immediately, and we can look at this and you can see where it's going to be. And usually what you want to do is you want to just put it so whichever one looks like it almost disappears. I would say it's between 7 and 8, which is what I would have expected based on what's in there. Maybe a little closer to 8. It looks kind of a little more darker green than the sort of lime green color right here. And again, I don't know how well the color is going to show up on screen. So, okay. Obviously, for drinking water, you don't want. You don't want anything. You want something in the 7 maybe to 9 range. If you have anything at 10 or 11, that's probably too alkaline. If you have anything down in the 4 or 5 range, it's probably too acidic. If you have a lot of carbon dioxide, 4 or 5 is probably okay. 4 or 5 is probably better than 10 or 11. Okay, so again, you can kind of just go with that. And okay, so let's check on the phosphate. Doesn't look like anything's happening, but we'll see. I didn't put much in, but we'll maybe let that sit for a second. Let me talk about this other test that we do. And this is the one we're going to rely on pretty much for most of our bacterial, at least in terms of publications or anything like that. So this test right here is from a company called IDEX, and there's a lot of things that you have to do. One is you have to collect a sterile, a water sample in a sterile cup. Okay, and this is specifically based on 100 milliliters of water in order to do this test. So what you do is you simply just go out and carefully take this cap off, collect the water sample, and put the cap back on immediately, and then just lock it in place. Okay? So if it's not opened, it's sterile. Okay? They come that way from the company. And you can order these from just about any scientific supply company. These in particular I got from Fisher Scientific, but you can get them from VWR, Thomas Scientific, or pretty much any other, even a microbiology company that does tests. IDEX, okay, what you do is then you dissolve what's called the reagent pillow. This is specifically called Enteralert, okay? And it's 1 per 100 milliliter sample. And what this is a reagent for bacterial growth that also includes a fluorescent reagent that binds to the bacterial cell wall. So when that reagent binds to the cell wall in the bacteria, it glows, it'll fluoresce. Okay? Now what you have to do is you dissolve one of these pillows in the water sample, then you pour the water sample in, and I'm not going to open this because it is sterile. You open this and then pour it in, and then I don't have the sealer set up, but what you have to do is run it through a thermal sealer, and it seals this up. And you want to make sure that you have, in order to guarantee that all the trays are filled, what you have to do is you just make sure that when you put in the 100 ml sample that you have sufficient fluid that comes up this far. That'll guarantee that everything is filled. Okay? Then you incubate this for 24 hours at 37 degrees Celsius. Standard incubation. They say anywhere between 37 and 40. Okay? So if you have a biological incubator, I don't have one in this lab, but we have some downstairs, and that's what we're going to use. Okay. And so then after that period of time, what you do then is you put this into a light box, and I've got one right here. This is a UV light box. We use it for chromatography also. So what you do is you turn on the UV lamp, and there's 2 of them, and I think you use the long wavelength lamp. Okay. And then you simply count up the number of wells that fluoresce. And the fluorescent color is a blue color. Okay, not yellow, not fluorescent yellow. It's a fluorescent blue color, kind of almost like a firefly, except not quite as greenish as a firefly. It's a little more bluish tint. You count them up, and what IDEX provides, it's a statistical test, and what IDEX provides is a table. And you count up the large trays and then count up the small trays. And on the left side of the table, the left side is the large trays. And so you go down until you find that number. And then you go across until you find the number of small trays. And that number then, you look it up, and it gives you a statistical reading on how many bacterial, how many enterococci, per whatever volume they use, okay? And that's what we're going to report. And these are standard tests. You can use these for salt water, you can use them for fresh water. If you do them for salt water, you have to dilute your sample 1 to 10, okay? So if you're doing cistern water, it's a straight water sample. If you're using salt water like ocean water, you have to dilute it 1 to 10, okay? And they take that into account on the table. Okay. And in addition to that, there's a bunch of other tests we could do for metals and things like that, but that's mostly stuff that is higher end instrumentation. And we have to do that in the laboratory. We really can't do anything metals testing in the environment itself, on site. We've got a couple other instruments that we purchased, a handheld meter, which will do actual reading, dissolved oxygen, salinity, nitrate, nitrite, ammonium ion, ammonia itself, and then pH and dissolved oxygen. So we'll do all 7 or 8 of those simultaneously. It's a Yellow Springs instrument meter with a dipping probe, so I can actually take it out and just dip into somebody's cistern and do that. But this gives us more, a little more freedom to do it a little more quickly. So this is just a rough set of tests that you can do. If you have a high coliform reading on this sort of test, then I recommend that you have it done, professionally to make sure what's going on. If you have a high phosphate level, you might have had somebody dump some detergents, accidentally into your cistern or something like that. But again, a lot of this is more just to advise this sort of stuff right here. All right, well, thank you very much. I hope everyone has a good day, and I'm sorry I won't be able to attend in Puerto Rico, but I wish everyone well. We're all recovering right now, so. All right, thank you very much.